Um, there is a table that I included in your notes. It's about it's related to chapter 2, part 3. It's related to chapter 2, part 3. Let me close some files here because otherwise they will disturb me. Sorry, what's happening now? Oh, here it is. Let me show you the table that I'm talking about. You must familiarize yourself with this table because you will need it as we continue. But I want to explain on how to use the table, and we'll do an example because already we have what we have something a data set that we already used, so it will be easier for us to use this table. So let me share the table with you before I continue to another section. Okay. Can you see the table?
Yes, sir.
So the table is about checking the adequacy of the model, or remember, each and every model has some assumptions, right? Each and every model has some assumptions. Same applies to the ANOVA table. ANOVA table, we have some assumptions that must be followed when constructing an ANOVA table. So this is one of the tests that we'll be dealing with, which is checking the homogeneity of variance test. We'll be checking if the variance from each treatment, remember, at first we're checking if the means are what? The means are the same, right? From each treatment. Now, this table is only meant to check if the to check if the variances are equal or not. The variances from each treatment are equal or not. So to understand the table works like this. The two, the one that I'm highlighting now, that's where you will get what? It represents the number of treatments from your problem. K, sometimes we can use T. In our case, we use T, but the default one there, they say K. So these two here represent that. It means from your problem, you have how many treatments? 2. If you see 3, it means you are saying we have 3 treatments, 4 treatments, and so forth. This other one here, where you say n minus 1, you have to calculate these other degrees of freedom. This one, I will show you how to do it now. So we'll do an example where we are having what? We're having a balanced problem. The reason why I have to do this problem again is because someone asked me yesterday that how do we find a mean? How do we find how do we find a sample standard, sample variance? This is related to sample variance. So if you don't know how to find the sample variance, it will be what? A serious problem. We are going to have a serious problem. So I want us to work together. We do an example together, and then I will now give you a task to go and do what? Apply the same procedure to the class example. I want us to do this one together. This is a certain example. From there, we go and do I will give you a task to do our class example. So what I'm going to do now, I want to give you a certain data set and show you how to use this table. Or we can use the class example. I show you how to find what? The sample variance. The sample variance, this table, you have it from your notes. So from the heading here, it shows that the upper value from each box goes with what? The upper value from each box goes with 0.05, and the lower value from each box goes with what? So it means this table is 2-in-1. It's having values for 5%, and it's also having values for what? 10%. Is it what? 1%. 1% and 5%. So don't confuse these two values. This 199 goes with what? Goes with 10%. This one, the one that I'm highlighting now, it goes with what? 5%. So this table is having information for 5% and information for 1%. So how do you find the mean, guys? How do you find how do you find the the sample variance? It's fine. Let's just use the class example. Let's just use the class example to save time. That example that we did, guys, is it from the node or is from the tutorials? The one that we were using yesterday.
It's from the notes, sir.
The ones that I'm projecting now. The class notes.
Yeah.
Okay, let me go to that example. The 2 part 1. Someone's mic is on. I don't know. Do we remove him from class or we ask him to mute his mic? We have that option. So let's use the class example. 1, 2, 3, 4, 5, 6, 7. Okay, we can use one for balanced and one for unbalanced. I will explain the difference. So suppose we are using this example, guys. Find the mean of, you have the mean for each treatment, right?
Yes.
So now I want you guys to find the standard deviation for each treatment. The standard deviation for each treatment. How do we find the standard deviation? Anyone who still recall how to find the variance for each treatment? How do you find the variance for each treatment?
SSE over n minus 1.
The variance for each treatment. Obviously, we're going to have different values, right? So for the first group here, program 1, you can use this formula. In our case, you can correct me if you are seeing the formula for the first time. I remember the shortcut. This shortcut, maybe treatment 1, S1. I was referring to treatment 1. It means summation of Yij minus summation of Y all squared over n divided by n minus 1. Is it not this the sample variance? Because if we're using the notation of x, we write it as summation of x1 squared, right? You correct me if I'm wrong. Minus summation of x all squared over n. Isn't it, guys? This is not the formula for the sample variance. This one, if we're using the x notation.
Yes, correct.
Yes, correct.
So now, because we are given the y values, you use this formula. So please, you have to find the what? You have to find the variances for each treatment. So it means now you assume that you have only the information for what? Information for first treatment. You find using the information for treatment 1, find the variance there. So it means you must know the sum of what? of your first treatment. You must know how many values you are adding. Your n there, it means your n is what? Your n, it means going to be 8, right? Because you are having 8 values from that thing, that treatment. And then you square all the values for the first treatment minus the sum of all those values divided by n. Is it difficult? Is it difficult, guys, to do that?
Sir, please repeat.
Repeat, sir.
Do you understand the first notation? This one?
Yes.
Please repeat it,
You
sir.
repeat which part, my sister? When you say repeat, I don't know which one to repeat because I said a lot of things.
How we use the first formula.
You are focusing on assuming that this is your data set, leadership. Let me remove this. So it means you guys, you didn't do the task yesterday. I asked you to go and know and find the standard deviations for each treatment yesterday, the variances for each treatment after giving you that after giving you the other formula for the error. I asked you to go and check on how to find the variance for each treatment. Suppose you have this information, P1, the values for P1 is 2, 7, 9, 12. Find the variance here. You have 4 values. How are we going to find the variance? That's my question. Find the variance here. You have 4 values. Find the variance of this treatment. How are you going to do it? There is the formula up there. Yes.
So, according to the notion which you are trying to make us understand, is that you are saying per treatment we are going to find the variance, and for us to
Yes.
find the variance, we must know the mean of that treatment so that we can find the deviation of the square deviation of that treatment. Per treatment, then we divide by n plus 1, and that is the simple standard variance equation.
Yes, you can use any formula as long as we reach the same destination. There are different formulas that we can use, isn't it? There are different notations that we can use. So how are you going to first find the first part, my sister? How are you going to find this first part?
Yeah, we squared the all values here.
Okay. Minus the summation of y.
We sum all the values and run square.
And square. Yes, and
Divide
the
by
n in this case is what? The n is
4.
what?
4.
The n is 4. Yes.
Yeah.
And then that's all. And the rest is the right. N equal to 4 in this case. So you have your n, you have your n. So it means this part is covered. This one, you sum all the values, the 4 values, you sum them first. From there, you square them. This guys, this is a first year thing, isn't it? Yeah, thank you very much, leadership. He's saying the information is there in the calculator. Thank you very much, my brother. You saved me. He's saying the information is there in the calculator. So you store the values, these 4 values, and my sister, you just joined now. Katakan, you just joined. Yeah, this is just an example. This is just an example, Katakan. It doesn't. In this case, I was saying is suppose you have information from your treatment 1 with those 4 values. Find the standard. Which one? Which one? Which one? Karabo, what are you referring to? Please, you must know the difference between. You must know the difference between sample standard deviation and did you square the value after finding? Because what you get from the calculator, I assume is what? What you find from the calculator, I assume is the sample standard deviation. It's not the variance.
Yeah, after doing that, I squared my answer and I got 8.1875 for the.
What are you getting?
The
Yes,
8.18
Makwelelo.
in the.
Yes, Makwelelo.
Confirm the formula.
My formula.
Can you hear?
Yeah, I can hear the second speaker now. The first speaker, I couldn't hear him. You are breaking, my brother.
Okay, I'm saying that when I'm checking to ver. Can you hear me now, sir?
I can hear you. Or check this one.
Oh, it seems like there is no.
There is no what? There are two notations of that we can use in it. Check this one. That the one that was asked by but people are saying they're getting different answers. I don't know, because guys, as I'm saying, we're not in a level where you cannot say you don't know how to find the standard deviation. But now I took almost 20 minutes trying to explain how to find the standard deviation, something that you're supposed to know from first year. So you can also use this one. If the other one you are failing to use the other one, use this one. It means if you use this one, you say the first value from that treatment minus the mean, plus you square it, plus the second value minus the mean, plus that mean, the same mean, until you get to the end. Divide by r minus n minus 1, which is how many replications do you have there. Raymond?
Yes, sir.
How did you get your mean? How did you get your, because people are getting different answers?
I used that first formula that you wrote.
Yes. You got what? You got the same thing? Are you not
Yes,
getting
it's
the same thing that you're getting from the calculator?
It's the same thing.
Can you please educate these guys? Because that's what I'm saying now. We have to push, guys. Some people even now they don't know how to find the mean. Sorry, they don't know how to find the standard deviation. Can you please explain how you got it, my brother? You are saying I should write the first formula, right?
Yeah. Then
let me write it. Minus summation of y. This one is y dot dot based on our notation now. Squared over n. Divide everything by n minus 1. It's the same thing as what I wrote up here. It's the same thing. This is the same thing. If you change the notation, it's the same thing. So now, can you please explain, Raymond?
Then the sum of yi squared is 2050.
Wait, let me write it. He's saying he got 2050. This one is 20. What are you getting, you guys? Were the ones who are getting it different, but 2050.
Yes, and then the sum of yi is 126.
You are using which example, my brother?
Sorry?
You are using which example? The class example or?
Yes, the class example of program 1, program 2, program 3.
Okay. And your replication was 8, right?
Yes.
Guys, Raymond said he used the class example. When he used the calculator, and when you use the formula, he's getting the same thing. So I'm surprised why you guys are not getting what Raymond is getting. It's not the only one who said the formula is working. So it means now we have a challenge where you guys, you don't know how to find what the standard deviation. Kulfelo got the same thing. Sirare Mary got the same thing. Homu also got the same thing. We have a visitor today, guys. Can you see what is happening now? Yeah, so guys, now it means we have a challenge. This one it means you have to find guys who can help you to do these things. We have a visitor in the house, guys. The person now is busy tampering with my screen here. So those who don't know how to find the thingy, the standard deviation, please make sure that you check the guys who managed to, who are able to find the mean, please. So give me this information. You have program here because we have to move now. Today we won't have a break. Ne? Program 1, program 2, program 3. Give me the mean of the program 1. Mean for program 1. From class example, I don't want to confuse you guys. From class example, give me the mean for program 1. Is that the mean? 15 point. Thank you. 15.75. Mean for program 2.
14.625.
Thank you. Mean for program 3.
17.625.
Give me the variances for each.
9.3571.
Yes. Thank you. Variance for the second treatment.
12.8392.
Yeah, we're moving because now I notice people now they know how to find. So please, guys, you cannot. The last one, whatever you have done from first year, we need that knowledge. 9.9821. So, based on this, and so we need this information now for you to check for if the variance is constant or not. You need, if there's no difference. Sorry, if there's no difference between the variances. Now we're going to assess this. Now we're going to assess this part here. At first, remember, we're checking if the means are the same, right? Now we're moving to this one. We have to check if the variances are equal or not. We have to check if the variances are equal or not. So we're going to use what? To check for if the variance, equality of variances, we're going to use Hartley's test. Hartley's test. We are going to perform Hartley's test. So it's possible that I can ask you to check for the if the variances are the same or not using Hartley's test. We have different tests that we can do. We have Levin test, but the procedure is different. We have a lot of tests that we can do, but for now, let's only focus on the Hartley's test. We're going to check if the variances from each program are the same or different. That's what we are interested in now. So there's a document that I prepared for you guys.
Sir.
Yes.
Oh, since I joined late this session, now we are testing for we are testing for the equality of the variances now.
Yes.
We moved away from the estimator mean. We're on the
Yes,
other
we're moving away
estimator.
from the mean part. I'm done. Now I'm coming to a new thing. We're checking. I'm about to talk about it now, my brother. I'm about to talk about it. We have people who are making noise from the background. Please. So I'm about to share some this document, which talks to what we're doing now and how to use this method. Let me share the document with you. So since now you must know always if you are asked to test for the equality of the variances, you are going to use what? I would expect you to use the at least test. But I'm not saying this is not the only test that you can perform. We have other tests, like as I've indicated, you can use Levine. There are many tests that you can apply. We have a lot of tests that we can apply, but now I want us to focus only on this one here. I'm coming. So our quiz is still on for Friday. Make sure that you prepare for the quiz.
What time are we writing, sir?
In the morning, 7:15. 7:15, you'll be writing on Friday. We are going to use our consultation session for the quiz. Did I answer your question, Mabunda?
Oh, sir. What
Yes.
you are teaching, the notion you are teaching now, is it part of the upcoming assessment?
The
The
part that
Friday
I'm
one.
teaching now, yes, even everything that we are going to cover this week is part of the quiz. I will even finish the second document. It doesn't need a lot of time. So I think the quiz will be based on chapter 1 and chapter 2. Because the main reason for the quiz is to prepare for the test, right? Isn't it?
You are right.
Yes, we are preparing, so you don't have to blame yourself if you get some challenges during the quiz. It means you know where to correct, isn't it, before the main thing, which is the test. But I'm not saying don't take the quizzes serious. So we have, can you see the shared document? The reason why I have to cover this part is for you to understand why we have to, sorry, there's a mistake here. We're simply saying that the assumptions of the ANOVA table. Remember, we constructed an ANOVA table, but there are some assumptions that need to be followed when constructing an ANOVA table. So the analysis of variance technique also makes certain assumptions about the data being investigated. The data being investigated, like the one that we're having there. There are three major assumptions in the analysis of variance. These assumptions, guys, you know them from first semester, those who were with us in the first semester. Normality. How do you check normality assumption? Which graph can be used to check for the normality assumption? Guys, those who did the regression, they have to know this part. I won't blame those who just joined now.
Histogram.
Histogram of what? Histogram of errors, right? Or, here it is indicated here. You can also use what? You can also use box plot. or you can also use what? Normality probability plot, the QQ plot. Remember the QQ plot? So I will share this document with you guys. QQ plot. You can also use the QQ plot or box plot. It means when coming to box plot, you will have the box plot for each and every treatment. You know, I assume you know how to construct the box plot. Why do we need to construct the box plot? Guys, why do you need to construct the box plot? Guys, now you are disappointing. Sorry?
Quartile.
Let's give me the 5-number summary. 5-number summary is what?
The max, the mean,
Mean,
the first.
max,
Interquartile,
Q1, yeah, Q1, Q2. This question I assume is there in your tutorial, right? You don't have this question for my tutorial. Why I said draw a box. You don't have this question. Why I said draw a box plot.
No.
Are you sure? From my tutorial
No.
questions, this question is not there. So you must know, guys, how to draw a box plot, or you must know how to explain a box plot. If I can give you the box plot, you must be able to tell me what is happening there. So again, I don't think you expect us to teach you how to find the quartiles, but you have to know how to find these things. You have to know how to find the minimum value, the maximum value, Q1, how to calculate Q1, Q2, and Q3. You must know these things, guys. You are senior students. You don't learn to forget, right? So please. So now, the one that we need us to calculate check if the variances are equal or not is the third assumption. So the 3 measure assumptions that we need to check for ANOVA table: 1 is normality, 2 is the randomness. Why do we have to apply randomization, guys? I want to check. Why do I apply randomization? One way to explain that, or two ways
we
to
eliminate unbiasedness.
Thank you. Thank you. So you know why you have to. The errors are not supposed to be related. The errors should be independent. So if the data is random, and then we expect even the errors to give us a same thing, where you find that the errors now, they don't show any pattern. So that's what we mean by that. But with this, the first two, you have to know that if you have to check the normality assumption. What material do you need to do that? You must know that if I have to check the normality assumption, I need the box plot of the box plot. I need I need the normality plot, or I need the histogram of errors. You have to know that. When coming to the randomness, you must know that you assess a plot. You don't want to see a pattern of errors forming a certain pattern. Because even here, that's why I'm saying I'll give you these notes. You will go through them, and wherever you don't understand, I will be there for you. So the last assumption, this one goes with what? This goes with what we want to. This goes with what we want to discuss now. Homogeneity of variance. This is the third assumption that one needs to know. So maybe if you allow me to close this. Homogeneity of variance. Can you please give me the 3 measure assumptions of ANOVA? Can someone give me the 3 measure assumptions of ANOVA? We just discussed them now. The 3. 1.
Normality, randomness, and independent of errors. Homogeneity of variance.
Thank you very much. Homogeneity of variance, independent of errors or randomness, normality. Now, what is left for you guys is to know how to check for these three assumptions. So the only one that we'll be focusing on for today, which needs some calculations, is the third assumption, which is what? Which is the random, the what? Homogeneity of the errors. So our focus is on this one. That's where you'll apply what? That's where you'll apply the heartless test. Is there any question? No, I was not presenting anything. I minimized the thing first. So this is the test. So this is the test that we'll be focusing on for now. The third test, which is homogeneity of variance. Your null hypothesis. This is the simplest test to perform, guys. This is the simplest test to perform. So your null hypothesis will say, let me close this. So now you know that we're focusing on the third assumption. So to calculate or to apply this procedure, you need the what? You need the sample variances. Oh, sorry, I need the whiteboard. You need, for you to perform that one, which is talking about the variance, you need this part. You need this part. I will explain the null and the alternative hypothesis, but now I'm interested in showing how to find the F calculated, F max. We usually call it F max. F max is the largest variance divided by the smallest variance. Someone is writing on my board, guys. The largest variance, which one is the largest variance, guys? And which one is the smallest? You did this from your first year, I know this one. The largest divided by the smallest. Which one is the largest variance there?
12,839.
So always, even if you have 5 variances, the largest, you put it on top. The smallest is the denominator. Do we get that part? I want to give you the steps now. So, thank you very much. Thank you very much. So I want to remove this, and now I want to give you the steps that need to be followed. Your null hypothesis. Now while you are testing for the variances, it will say variance 1 for program 1 is equal to variance of program 2 is equal to variance of program 3. That is the first part, guys. H1 will say what? H1 will say H1 will say at least one of the variances differ, isn't it? Guys, are you with me?
Yes.
Yes.
Thank you.
Yes.
Thank you. I don't want to talk alone. So at least one is different, isn't it? At least one of the variances is different, isn't it? At least one of the sigma squared I differ, isn't it? Differ with the other one. At least you understand the meaning of at least. We must put at least here. Don't be surprised, guys. The way I'm writing now, we don't have the necessary resources. Yes, Glenn?
So when you say at least, meaning it's possible for all the variances not to be the same.
Yes.
Also, I'll be wrong if I say not all variances are the same. I'll be wrong if I say that.
You'll be right. But you must make sure that you come up with a statement which caters for all these possible options. I heard the first one, it says variance of first program is the same as variance of the second program is the same as variance of the third program, isn't it?
Yes, sir.
Yes. So come up with a statement which can oppose that one.
I noted.
That was a one. Yes. So now,
Noted.
suppose we use alpha of 5%. 5%. We're fine with this one. F statistic, F max, which is F calculated, will be given by the largest variance, S squared large divided by S squared small. You said you are getting what here? You said what are we getting? Give me the value so that
1.372.
is you got it by doing what? 12 point what?
12.839 divided by 9.3571.
839 divided by 9.3571. 3.51. You are getting what, leadership?
1.372.
1.37. Confirmed by leadership there. So now we have these guys. So the tricky part is the next step now. You see, so far, to get the first three steps is easy, right? You just write the null, the alternative. You find the F critical F calculated there. Always you put the larger variance on top, divide by the smallest, looking at the what? The information from your problem. And then now we're moving to a case where to find the value from the table. This is the part where you have to pay attention. It says, let me remove this, erase. Oh, let me just clear everything. We have the values there. So it means we have F. To find the value from the table, you must do some calculations first. F of t, usually they call it n minus 1. The t is the number of treatments, right? How many treatments do we have?
3.
4, isn't it? So this one, they say what? N bar. N bar representing what? You must find the mean of n before you subtract it from 1. The mean of n is what?
No, number.
You count the number of replications. Yes?
First 3.
The number of
It's
treatments is
3.
3.
It's 4.
Three.
It's 3.
Number of treatment is 3.
It's 3.
Someone said it's 4. You heard him, right? So I'm not the only one. So I'm told here is 3. Thank you, leadership. So now to find the n bar, you count the number of replications from each treatment. What is the replications for the first treatment? Number of from the first treatment?
8.
Second treatment?
8.
8.
Treatment?
8.
That is fine. It's fine. Thank you. You divide by what? You divide by the total number of treatments, which is what? What are we getting? It's 8, right? 8 minus 1 is what? Is 7, right? So now the value that we're going to check from the table is f of 3 and what? And 7. What is the answer? 5% table. We use what? We agreed we are going to use. You don't use that any table, right? We use the one that is meant for the testing for the variances. We agreed that is the Atlas table. So let me go back to the Atlas. You have this table, I repeat. You have this table from your notes. Wait, Mangani, I'll come back to you. I'll get back to you, Mangani. You have 3 and 7. What is the value? Using 5%. I want to check if you understood when I was explaining this table. You have 3 and 7. What is the value? Can someone use the mic? Anyone who want to explain how we got the value?
6.94.
How did you get it? Can someone help us to? Can someone explain how we got 6.94?
Sir.
All right.
Okay.
Can you please raise up your hand so that we need order here. If you want to say something, please just raise up your hand and then yes. Let me check. Wait, I'll tell you. Yes, I think it's Desmond who came first. Shokani.
Yes, sir. Yes. Yeah. Hello. Sir,
Can
can
hear
you
you,
hear me?
Shokani. Yes.
No, it's Ntako, not Shokan.
Okay, it's fine. Continue, Tako.
Hello? Okay,
Yes,
no.
we can. We are
I agree.
listening.
The degrees of freedom. Yes, the degrees of
Yes.
freedom, it's 7 because it's a n minus, which is 8, is n minus 1, we got 7. And then
Yes.
the number of treatment, it was 3. And then we go with that row, yeah, 3, ne? Fika like
Yes.
7. When you check the value there, it's 6.
So why didn't you take the 12.1? Tako? Why not 12.1? Thank you very much. As I've indicated, the values in this box, one value is for 2%, 5%, the other value is for 1%. So you have to be careful when using this table. Unless in a test or a quiz, I decide to give you a table which is only having values for 5%, then you are safe. But if the table is like this, you have to be careful. So we have the values, right? And Taco, sorry, not Taco. Mangani, what were you saying? Mangani? So are we fine with the table, guys? How to use the table? Monday?
Sir.
Let me get Monday first, and then you'll come in. And Mangani,
Sir.
let me get, yes.
I did not understand why 6.94, not 12.1. Can you explain?
Please focus on this, the heading of this table, right? I'm going up now. Can you check the notation there up there? It says what? The upper value in each box is for 5%, and the lower value from each box is for 1%.
Okay,
Did I
okay,
answer?
I understand. Yeah.
Thank you. Mangani?
Sir,
Yes.
I wanted to confirm that when we get F max, we are on the F tabulated. That N bar is the total of, like, we add number of replication of each treatment divide by
Yes.
treatment.
You minus one. You minus one first, right?
Hmm? No, I mean when we get N bar.
Oh, okay. That one is
That
fine.
3 is for. I understand the top one is we are adding the replication of each treatment.
It's fine.
I mean,
What? Let's go to this one, my sister. How do we find the what? The mean? The sum of observations. So how many values do you have? That you have. You have said you have 8, right? How many values are you having?
4.
How many values? No. How did you get the 24? Let me go back. I understand. Let me go back just to the thing. Sorry, I cannot close this because I will need it later. Let me go back to the whiteboard. I think Mangani, you are questioning this this 3.
Yeah. Oh, I wanted to confirm if it's for the treatment now, total number of
The number
treatment.
is the number of values that we have added.
Oh, okay.
It will always be the same as the number of treatment. Because if you are having 4 treatment, I expect you to come up with the replications from each thing, each treatment. Are you fine?
Yes. Thank you.
Manyama, your hand was up. So what did we get? We got 6.994. What is our conclusion, guys? What is our conclusion? I'll come back to you, my brother. Are you rejecting the null hypothesis or failing to reject the null hypothesis? F cal is what? F cal is what? Can someone remind me about the F cal? I was told it's 1 point something. 1 point. I think it's
reject.
1 point. Thank you. You failed to reject, right? You failed to reject, and what is your conclusion? What is your conclusion?
That all the variances are equal.
The variances are equal, right?
There's no difference between.
There's no difference between the variances. So suppose. So I want to give you an example in a case where we're having different replications. The difference will be where, guys? The difference will be on the what? So it means if you have different replications, it means the only part that will be affected is this one, isn't it? Finding the standard variance for each treatment, you know the steps of doing that. So if you don't have equal replications, for you to find N bar, let's check the one of the diet. Let me check this example from your notes. Let's check this one. Let me share this one with you. So please, guys, try to go through these notes, because otherwise, if you are not doing your part, it's a problem. Can we? What will be our F calculated? F tabulated here? What will be our F tabulated when testing for the what? The variances. What will be F? I know the question is not about that, but I can add it for the upcoming tutorial. What will be our F? How many replications from the first diet?
3.
And the second diet
is 5.
And the last one, when you add everything, what are you getting?
12.
4.
Someone saying 12, someone saying 4. Which is which? So When you go to the table, you will say what? So if the problem is not balanced, the only difference is when you find what? The only difference is when you find the F. Let me clear this. So as I have indicated, some other textbooks, they will use what? They will use what? They will use, I'm coming, Manyama. Let's take 5%. So for this one is F of how many treatments? 3. How do you find N bar? N bar is equal to, you said 3 plus 5 plus what?
Plus 4.
Plus 4.
Yes.
Which is what? Which is 12, isn't it?
Yeah.
Yes.
And then you have to divide this by what?
3.
3. And then you are getting what?
4.
You are getting
4.
4. So you are going to check. So you will check F and what? F for 3 and 4. Is it difficult, guys?
3 and 3, sir.
3 and 3.
Yes.
How?
Because 4 is the N
It's 3
bar.
and
4
3.
minus 1.
It's 4 minus 1.
4 minus
4
1,
minus,
sir.
4 minus 1 is. Oh, thank you, thank you, thank you, thank you, thank you very much. I was getting lost also. Thank you. You N minus 1. After finding the average minus 1, you will get 3 and 3. You go to that table and then you make conclusions. So that's what I wanted to explain about the 3 measure assumptions of the analysis of variance before I can move to the next section, which is testing for. It's also related to this one, but now we're not testing for. The next section that we're going to deal with now, we're testing if, we're no longer testing the equality of variances, but we're going to test if the variance of the treatments, this is the next section, if the variance of the treatment is equal to 0, or if the variance of the treatment is greater than 0. This is what we're going to test the next section. You see, this one is the variance of the tau. So the next section is about testing for the variance, if the variance is equal to 0 or if the variance is greater than 0. Don't confuse the two. The test that we're dealing with now, we're testing if the variances from each treatment are equal. Isn't it? We're not testing if the variances from each treatment are equal to 0. We're testing if the variances for each treatment are equal. So this one, we're testing if the variance of the treatment is equal to 0 or the variance of the treatment effect is greater than 0. That is the next section that we're going to cover, which is chapter 2, part 2. The one that I'm going to share now. So the athlete test, we can make sure, yes?
When we're calculating the F tabulated, are they not the same for unbalanced and balanced?
For which one? It's the
Both of
same.
them, like they're the
It's
same.
the same. It's the same.
Oh, I thought maybe they are different.
No, it's the same. It's the same.
Okay.
So it's the same, my brother. So I will also give you this note about these 3 measure assumptions of the ANOVA table. You have to understand them, because this thing of just enjoying to doing calculations, not even understanding why we're doing the calculations is wrong. We have to understand why are we doing these calculations, and so forth. So these things of enjoying to doing calculations without even understanding why we're doing that is totally unacceptable. So the next step is the run. Remember, I said we have a fixed effect models where we'll be testing for what? For the means. And we have a random effect model where we'll be testing for the variation. But the good thing about this method now, the one that we're about to discuss now, is constructing an ANOVA table. You construct it the same way you constructed that one for the fixed effect model. Yes?
Sir,
Yes.
my question is this: since a mean can be a real number, then the mean of the n can, if it's changing decimal places, what should I do as a statistician?
Yeah, background. If it's a TV, can you please reduce
Oh
the
no,
sound?
it's people there at Miss Building. Say, I was saying,
Oh yeah.
my
Oh,
question.
okay.
Yeah, I was saying, my concern now is to understand what is going to happen since the mean can be a real number. If the mean of the n is equals to a real number in such a manner that it is having decimal places, as a
Yes.
statistician,
Thank you very much.
what
You
is
focus on the
expected?
usually this method. You focus on a case where you are having what do you call this one? Um, you focus on the first part before the comma. It depends, but it also depends with the book that you are using. If you're having 4.2, you use 4. You ignore the 2, the 0.2 part. Manyama?
What if it's
So
4.9, sir?
if it's 4.9,
Then I'm saying, according to the technique, they say just focus on the first digit before comma. It doesn't matter what is on the other side. Are you still there?
is
If it's focus, you focus on the digit. You don't have to worry about what is on the other side of the comma. You focus on the first digit. But as you know, these guys, if we go to Levine, Levine can suggest a different thing because I think it's good you raise that question. Let me go back to this one because so that we're on the same page. Um, um, part 4 is this the notes? When coming to this test, brother, it's tricky. We have a lot of tests that are suggested um, based on this method. We have a lot of tests which are suggested because we can the Levine test only based on what I've checked, it only focuses on a problem which is balanced. On the problems which are balanced, like which does not have missing observations. That is the Levine test. So some of these tests they cannot work if the problem is not balanced, like the Levine test. But with ours, the what? According to the theory, it says if you are having a decimal, you make sure that you focus on what? On the first part of that of that number, which is anything before the comma. You only consider that. But you have to, since I'm not emphasizing that, you don't have to worry. I will give you something which you won't have decimals. Yeah. I will make sure that I give you something which does not have decimals, so that you don't get confused. And if you go and read another article, if you go and read another article, it say you can say 4.9, you can make it 5, and my article is different from yours. Now we'll start fighting, isn't it, Manya?
yes, and well understood, sir.
Yes. So I'll give you something related to what we're doing. I won't come up with something that we didn't discuss, like the one that we just did now. We got a whole number, right? So I'll try
Yes,
to
sir.
give you something related to what we're doing, because the main aim here is not to trick you guys, is to understand why we're doing these things, isn't it?
Yes, sir.
Thank you. So understand, don't confuse the what we're doing now and what I'm going to do right now. The second part, or where I'll be discussing um, the what? We'll be discussing the random effect models. Don't confuse it with what we're doing. What we're doing, we're checking what if the variances are equal. What I'll be doing now is to check if what I'm going to do now is to check if the variance is 0 or if the variance is more than 0, which is the second part of your notes. Feel free, guys, if you want to ask something. But since we still have the tutorials, you are safe. If you have more questions, we can discuss them during the tutorials. So this is the next section, guys, is the random effect in CRD. So here, the only difference, guys, which I won't expect you to do when you are answering this question, is how the selection was done. This is the only difference, how the selection was done. To construct the ANOVA table, you are still going to use the same process that we used when you are dealing with what? When you are dealing with the fixed effect model. So in a test, if I say assume model 2 is appropriate. If you check from my tutorials, sometimes I will say assume model 1 is appropriate. Whenever I say assume model 1 is appropriate, it means I'm saying assume you are testing for the means, if the means are equal or not. That's what I mean when I say assume model 1 is appropriate. If I say assume model 2 is appropriate, I'm simply saying test for. I simply I said there's no break leadership because you took my time trying to calculate the variance. So you took my time calculating the variance. So we won't have a break because of that. So this section, if you can check, there's only 12 pages, which doesn't even need 20 minutes to solve it or to do this section. So the random effect models is, let me go to that document. This is the document. The example of random effect model is this one. You want to draw inference on the population levels, not yes.
Sir, you said. Sir,
Yes, you can continue, Christopher. Yes.
You said if we assume model 2 is appropriate, what does it mean?
It means we are testing if the variance is equal to the variance of the treatment, means treatment is equal to 0, or the variance of the treatment effect is greater than 0. The hypothesis that we will be testing now. The only difference, my brother, is on the hypothesis, the H0 and H1. The other steps is the same as what? Or it's fine, let me just do it. Let me do it like this, summarize what is on that document, because there's nothing much, in fact, from that document. Let me do it. Model 1. Model 1 and model 2. Model 1 tests for the means. Model 2, you test for variance. not just the variance of tau I, which is when you write the hypothesis for this one, you say, if I say model 2 is appropriate, it means this is what we are testing. Sigma squared equal to 0. If I say model 1 is appropriate, we are testing for what? A0 mu 1 equal to mu 2 equal to mu t. Do you get it, my brother? Chris?
Yes, sir.
Oh, sorry.
Sir.
Yeah, I missed there's something important here that I missed. The variance of tau I is very, very important to put that sign. Yes?
Sir.
And now, yes? Who's talking?
Me. On model 1 is test for what?
Test for the means.
Oh, okay, thank you.
I think from your tutorial, you saw something like this, isn't it? Where I said, assume model 1 is appropriate. Isn't it, my sister? From my tutorial question. I think from my tutorial, I wrote something like that. So now I'm saying when coming to constructing an ANOVA table, the procedure is the same. You just construct the ANOVA table the way you've been doing, but the only difference is that is the hypothesis, which is the first part, this part, and the conclusion obviously to be affected, because here you are not testing for the means, right? We are testing if the variance of the treatment means is greater than 0, is equal to 0, or greater than 0. So I won't ask you to come up with an example where it's a random effect model. No, I'll give you a question, but you have to understand what I'm looking from you. There's a possibility that I can ask you to test for if there's a what is the variability from between what the treatment means, the treatment effect, which is, it means I'm asking you to test for the second model. And again, equal to 0. Equal to 0. Remember, the variance has to be positive, right? The variance cannot be 0, isn't it? Sminya? Can we have a negative variance? Thank you. She understand. So let me share the notes again. So this is all about chapter 2 is all about that. So here, if you can check, there are 2 examples. There's an example which is related to fixed effect models, and there's an example related to random effect models. So I'm saying an example: compare reading ability of 10 second grade classes in New York. That's the fixed effect model. Compare the variability among all, you see, all second grade classes in New York. This one is called what? A random effect model. But you don't have to worry about doing all these experiments, because your focus should be on what? On how to test for model 2, which is the random effect model. So please go through this note. Yeah, what I was trying to explain is that you know this model, guys, from the fixed effect model. The model is going to remain the same. I agree that this is the population mean, the effect of the eyes treatments, errors are normally distributed around the mean of 0. These things, they are still the same. But sorry. instead of assuming that sigma summation of tau i's is equal to 0, you will say summation of tau i's is normally distributed around the mean of 0 and what? It's no longer sigma squared. It's sigma squared and there's what? A subscript tau there. There's a subscript tau there. So to show that now you are moving to what? To the random effect models. My screen is not that okay. So an example based, so this other part where it's talking about the covariance, you don't have to worry about it. The part that you have to understand is this one. Whenever you are asked to, you'll be asked to calculate for these two. Oh, sorry. Oh, I'm used to working from Word, but now because this is PDF, I'm trying to highlight. You must know how to find the what? The total variance, which is given by, from the fixed effect model, remember the total variance is what? Is sigma squared. But from random effect model, the total variance is given by what? Sigma squared tau plus sigma squared. I'll give you the formulas for how to calculate this during the tutorials. I'll give you the formula and I'll show you how to do it during the tutorials. We won't have enough time to do it now. So the part that I wanted to explain is this one. Yes? Mashudu?
So that total variance is it's a SSE divided by n minus 1.
Which one? I'll give you the formula because you
The
need the
total
formula to
variance.
find. There's a formula to find this part here, my brother. You see this part, variance of tau, variance of the treatment effect. There's a formula that I'm saying I'll give you the formula during the tutorials in the afternoon. So we're going to do these things together in the afternoon during the tutorials. I'm just pushing to explain the hypothesis because this is the only part that is important for this section. So we'll do it together, my brother, during the tutorials, right? So you don't have to worry about this. What's another formula here? Because the notes that I'm sharing now, we have to be careful with the notation. It's different from the notation that I've been giving you. So I don't want to confuse you. So I want to give you a notation related to the notation that I gave you before. So this is the hypothesis that we'll be testing, guys. This is the hypothesis that we'll be testing. If I say test for the variability, it means it's the variance, isn't it? The variation. I cannot say test for the means and then you try to test for the variability. Variability, it goes with the what? The variance. So if I check if test for the variability, it means I'm simply saying test for this hypothesis. Constructing an ANOVA table, still the same way. Finding the value from the table is still the same way. Can someone explain why now we're using the capital letter N instead of small letter n? Previously, we were saying n minus 2 minus t. Why now are we saying capital letter N minus t? The answer is here. Why are we using capital letter? Do you see the answer?
SST.
No, here's the answer. Why are we saying when we want to find the value from the table, we say t minus 1, capital letter N minus t. Why not small letter n? Let me show you the part. Why are we saying capital letter T here? Capital letter N. Yes? I'm listening. Thank you very much. So you'll go through the notes. So don't worry much about the notations that you'll see from this document. I'll give you notations that will relate to what we have been doing from the study guide. Because I noticed that some notations that I used here are different from the ones that I used from the study guide. So I will correct that. That's what I'm saying. Some of these things I will give you during the tutorials in the afternoon at 3. So here I was saying you write this hypothesis, you construct an ANOVA table the normal way the way you know it. You find the value from the F table, not the one that we used in the morning, and then you conclude. When you conclude based on these two. So I have an example that we are supposed to do. Where is that example? Here's the example, guys. Yes.
Sir.
Who's talking?
Shokan.
Who's talking? Shokan. Yes, my brother.
Can you please explain the end part, the connection?
I'm listening.
Can you please explain the end part? The connection kicked me out.
The end?
Yeah.
Are you able to check the chat? The chat. Someone. I'm not even the one who gave the answer. It's the leader from. Check the reading from Homu or Nekunguni.
I just reconnected right now. I didn't see.
So you cannot see the chat.
Yeah, I can't see them because I was out.
Or when you are kicked by the network, you cannot see what is written under chat.
Yeah.
Someone just wrote now because they are sure that you are not disconnected.
Yeah, I can see. Thank you, sir.
It's based on this part. It's based on this part. Go and check this second page from my notes. This second page. See here, where we're showing the difference between fixed effect models and random effect models. And check this part. The example that is given under B. Compare variability among all. All it means you are focusing on the whole population, isn't it, my brother? That's where now the capital letter N is coming in. But it's not going to affect your calculations. Even if you use the small letter N by mistake, it's not going to make problems for your calculations. Babunda, are you here? Babunda? So, here's the question, guys. Suppose we are given a question like this. So, here, suppose we have to apply model 2. Suppose we have to apply model 2, which means I'm simply saying, suppose you are asked to test for if the variance of the tau i's is equal to 0 or greater than 0. So you write that hypothesis, you construct a confidence interval for this problem. Then the way you know it how to construct a confidence interval, you find the value from the table, and then now when you test, you are checking if the variance of the tau I is equal to 0. That will be a conclusion, or it's not equal to 0. So there's an answer here. I think there's an answer based for this question. Here it is, guys. You can go and confirm what is here, and the what is what we managed to find here. And please do this problem again. What I'm going to explain now is this part. I'll give you the correct notation during the tutorials in the afternoon. I said there's a formula to find what? To find what sigma squared to estimate. Again here, you only estimate provided you have rejected the null hypothesis. Remember how to when it's necessary to do the pairwise comparison? When are we supposed to do the pairwise comparison?
When we reject.
When we reject. Even when coming to this section, you can only estimate the variance of the tau i's only if you have rejected the null hypothesis. But you can also get the formula from here that the variance of tau I is given by 36.93 is what? Is MST minus SSE, isn't it? Divide by what? Divide by, that's what I'm saying. For this one, I will give you the notes during the tutorials. I will give you the formula during the tutorials. So the why I wanted to cover this section is for me to come up with the what? The scope for the quiz. Yes, someone send this up.
Sir, if I heard you, it's Manyama, sir. Sir, you were saying the ANOVA. The ANOVA is the same for the two modules since they come from the same module, the module 1 and 2. The ANOVA is going to be
Hey,
the same.
your background, Manyama, is not is disturbing. But please raise up your voice. Your voice, please.
Sir, I'm saying.
Yes, I can hear you now.
Yeah, you can hear me. I'm saying.
Yes.
The ANOVA, since you are studying it from the same, the effect and the mean, since it's from the same model, the ANOVA won't change. Ne? It's only
The ANOVA won't change. Thank you very much.
Thank you, sir.
The ANOVA won't change because it's from the same. I think you explained it better than me. The ANOVA won't change because it's from the same model, which is mu plus tau I plus aij. The model is still the same. The ANOVA is going to be the same. The only difference will be what? On the hypothesis and how you conclude. So, due to time, guys, due to time, I'm supposed to explain the two confidence intervals related to, oh, it's three confidence intervals related to this section. It's possible we must find the confidence interval related to the sum of squares of the treatment, and another confidence interval related to the SSE. The SSE. So we need the confidence interval going with this one, with the treatments, and another SSE, and then another confidence interval which goes with the errors. And the last confidence interval is about the ratio. So this one, for the sake of time, I will cover it next week. So the scope for the quiz ends at this point. So the scope for the quiz is everything that we have done until today, except this part. So when you read this document, don't worry about this section. This is the confidence interval for sigma. The confidence interval for sigma is this one. I still have to give you the confidence interval for what? Sigma squared of tau. You see now you need what? You will need the chi-square table. So I don't want to confuse you because these tables now there are many. So for the upcoming quiz, don't worry about the confidence intervals related to model 2, because we need the confidence interval for the variance, which is this one, and another confidence interval for the variance of the treatment effect, which is sigma squared tau here. So for this confidence interval, don't worry for the upcoming quiz. they will form part of the test. So when you are preparing for the quiz, don't worry about this example. On page 12, again, there's another one here. Let me show you. So please don't worry about what I'm going. This one, the confidence interval for the ratio. Again, don't worry about this confidence interval. So whenever you read about the fixed effect models, yeah, don't worry about this formula. You see, it's so complicated. Don't worry about this formula. Here's the other confidence interval. You see, this is the confidence interval for this one for the ratio, or this one is for the variance. This one for the ratio. Oh. So there's three confidence. Oh, yeah, it is. Yes, this is the one. This is the confidence interval of the ratio, guys. So don't worry about this confidence interval for the upcoming quiz. 2, don't worry again about this confidence interval for the upcoming quiz. For section 2, the main part, the important part is to know how to what? For module 2, is to know how to find the ANOVA and what we are going to discuss in the afternoon. It's only 2 things that I'll discuss with you in the afternoon. From there, the scope for the quiz is enough. I thank you. Mabunda, are you here? Or Musibudi? Musibudi? If they're not here, we're continuing. If they're here, we can stop the class now. The scope I said is everything that we have discussed up to now. The tricky part I said is your responsibility to go and read about it. If Mabunda and Musibudi are not here, I'm continuing. Yes, they are my timekeepers. I don't know what time is it now. I wanted to stop. I don't know what time is it. But if they're not here, I'm continuing. No, we use the same tutorial, my brother. I'll
Sir,
just add one question where you have to apply.
they're having network problem.
Yeah, so we'll wait for them to rejoin. We'll wait here. Questions, please. We'll wait for them. Just call them. Just call them and say, we're waiting for you guys. We're failing to knock off because you are not here. Otherwise, I will cover these confidence intervals. And immediately I teach about these confidence intervals. They form part of the quiz. If you allow me to teach about these confidence intervals, they form part of the quiz.
Hello, sir. Good day.
John.
Good day, sir.
Yes, my brother.
I would like to ask on the previous lessons. What interval for different means for unbalanced?
Sorry?
What the difference, I mean, what the confidence interval of different means for unbalanced data?
For which question? For confidence interval?
Yeah.
Using which method?
Using which method? I mean, on the previous lessons.
Yes, but I must
like
first know which method you are talking about.
It just depends on what type of method I'm using.
It depends, because if for Turkey, and LSD, the procedure is similar, but for Newman, Kels, and Duncan, again the procedure is similar, but you cannot say for LSD and Duncan the method are similar. No. So suppose we are talking about LSD, isn't it, my brother? Let me give you an example of LSD.
Okay.
LSD. What is the formula for unbalanced LSD? The formula for unbalanced LSD is what, my brother? John, I'm waiting for you. T tab multiplied by the square root of, oh, sorry. Yes, Homer wrote it by my brother. MSE.
MSE into 1 over Ri plus 1 over Rj.
Yes. Ri plus, sometimes you can say 1 over Rj to show that this. So if it's the confidence interval, remember this part is inside the square root, right?
Yeah.
So I can do this. I can erase this. I can say yi dot minus y j dot plus or minus. There's the confidence interval, my brother. Guys, the class is officially over. You are that 10 minutes that I owe you is from now. So allow me to stop the recording. So if you want to leave, you can leave the session. That 10 minutes that I took now, I'm giving you back your 10 minutes. So I'm stopping.